Hello everybody, in this video we are going to talk about quadratic factors and their zeros. Now in previous videos we have actually talked about factoring a quadratic function into two parentheses. Well, what's inside those two parentheses are actually our factors because they're what we need to multiply to create the original quadratic function. But the zeros are actually another name for the x-intercepts. So we are going to be looking specifically where the parabola or the quadratic function crosses the x-axis. Now sometimes it crosses once, sometimes it crosses twice, and sometimes it won't cross at all. And those numbers can be positive, negative, whole numbers, and they could be fractions or decimals. So let's go ahead and look at a couple of examples that we're going to have to do. But before we do, let's talk about the steps that we're going to need to take in order for us to be able to work out these kinds of problems. So as you look at the screen here, we have a set of steps. So you are going to be given a quadratic function where it starts off with f of x. So our first thing we're going to do is either use our calculator or use a online calculator graphing like Desmos. Hello everybody, in this video we are going to talk about quadratic factors and their zeros. Now in some of the previous videos we have already factored quadratic functions, which means that we are breaking it down into two parentheses, and what's inside those two parentheses are expressions that we can then multiply and get our original quadratic function. Now zeros is just another way of saying x-intercepts. So what we're going to do is we're going to use the factors to find where the parabola or the quadratic function crosses the x-axis. Now please keep in mind that zeros, we can have 1 0, we can have 2 zeros, or we can have 0 zeros. And also the zeros of this function could be whole numbers. All right, so as you look at this first example, we do have this f of x. And so what I'm going to do is I'm using a TI Inspire to create my graph. And so if you have one, I'm going to walk you through those steps. If you're using something else, you can use something else to generate the table and the graph for this quadratic function. So the first thing I'm going to do is I'm going to start at my home screen. I'm going to hit 1. And I'm going to hit option 2 because I do want to add a graph. So notice that across the top, I'm going to take my function and type it in, 3x squared. And then we're going to do a positive 8x. And make sure you're using a -3 and not a -3 because a -3 will actually multiply some things. We're not trying to multiply, we're trying to subtract. Now when I hit enter, it is going to give me what this graph is going to look like. And as you can see on our graph, our parabola crosses the x-axis. So remember, this is our x-axis right here, and it crosses and touches in two different places. So anything that we do has to be an exact solution. So I'm going to hit Control T to generate a table. Now keep in mind that some of these numbers may be too big. Just find the ones that fit on this graph and then sketch the rest of it out. So for this one, I notice that these numbers are way too big over here. So I'm going to start with 1 and 8. So 1 and 8 would be here. Then I'm going to go up and do 0, -3. 0, -3. The next one would be -1, -8. Now keep in mind that I just added this graph, so maybe we will have to go a little bit further down, but not in this case, okay? So for this one, it's going to go to -2, -7. Right here. Now these ones are not going to be as nice as some of the other ones that we've been doing where they're kind of symmetric to each other. So just plot as many as you can. So here's -3, 0. And then the next one is -4, positive 13, which doesn't fit on this graph. Now please keep in mind that this down here is not our vertex. Our vertex is somewhere between here. Okay, so with that being said, let's go ahead and connect our dots the best way we can. All right, so as you can see, we did our best to connect these dots and form our U-shaped graph. So the main thing that we're taking from here is what the graph looks like. It's a graph that opens up. The second thing that we're going to use and need to compare is our x-intercept. So I can see that one of our x-intercepts is right here, and it goes through exactly the -3. Now the other x-intercept is right here, and notice that it's not 0, it's not +1, it's somewhere in between those two numbers. So in order for us to figure out exactly what those points are, we're going to use our factors, and we're going to set them equal to 0 to find the exact x values where it crosses. So bear with me here. We're going to go ahead and start our steps. So notice that we've already taken the f of x, replaced it with 0. I put mine in the back just because I'm used to my 0 being there. All right, so the next step, I'm going to go ahead and do my x down here at the bottom. And we're going to multiply, because we have a, b, and c. We're going to multiply a and c. I'm going to ignore the negative because I do want to remind you that I'm going to use the negative to remind me that we're looking for numbers that subtract to be 8. So remember, you're looking for numbers that subtract to be 8. So I'm going to put that at the bottom. When I multiply 3 times 3, I'm going to get a 9. So remember, I'm ignoring the negative and just multiplying 3 times 3. Now, because I'm looking for numbers that multiply to be 9, 9 is one of those numbers that don't have very many factors. So I know 1 times 9 gives us 9, 3 times 3 gives us 9. Those are the only numbers that multiply to be 9. So this is going to be pretty simple. Remember, you're looking for the numbers that subtract to give you 8. So if I subtract 3 from 3, it gives me 0, but 9 minus 1 gives me 8. So because I'm subtracting, I want to remind you that the signs are going to be different. So I'm going to say 9x and 1x. Because the 8 needs to be positive, then that means that the plus sign goes with the 9 and the minus sign goes with the 1. So positive 9 minus 1 will give me positive 8. All right, with that being said, this is what I'm going to use to replace my b value. So we're using all of our numbers. So we multiplied a and c. We found something to replace b with. So let's go ahead and rewrite it. We're going to say 3x to the second plus 9x minus 1x minus 3 equal 0. Okay, so we have expanded our b value into 2 terms, and the reason we're doing this is so we can have 4 terms and factor by grouping. So if you forgot how to factor by grouping, quick reminder to split it in half and then find the GCF. The biggest number that divides into 3 and 9 is 3, and they have one x in common. So even if they have both x's, you want the one with the smallest exponent. So we're going to take out 1x. So when we take this number here, we're going to divide both numbers and we're going to subtract both our exponents. Not from each other, but with the one that we took out. So 3 will go into 3 one time. And if you have 2 x's and take 1 away, we're left with 1. 9 divided by 3 gives us 3. If you had 1x and you took it away, you now have none. So no x's on the 3. Take your negative, bring it down. If it would have been a positive, I would have also brought it down. Now, the biggest number that divides into 1 and 3 is just 1. They don't have any x's in common, so I'm just going to divide by -1. When you divide by -1, it just flips the sign. So this -1x becomes a positive 1x. This -3 becomes a positive 3. Okay, I can tell that both of these are exactly the same, so I'm going to write it down once. 1x plus 3. I like to cross mine out. And then I'll take both of my GCFs and put them in the same parentheses, because that's what's left over. Now I'm going to bring down my equal 0, because I'm going to remind you these are my factors. So when I ask you to identify the factors, this is what they are. What's inside these parentheses are my factors. Now notice I can't divide this any further because they both have 1s inside, so that means nothing will divide out of it. So I'm going to take the first parentheses 1x plus 3 equals 0. Or if you want to leave off the 1, you can. I'm going to take the second parentheses and also set it equal to 0. And this is where I'm going to ask you to be careful. Even though we know how to solve an equation, sometimes we get a little confused when there's a 0 at the end because we're used to a number being there. So anytime it's 0, we're still solving for the x. So let's subtract 3 from both sides. Gives us 1x is equal to negative 3. If you divide both sides by 1, it still gives you x is equal to negative 3. Now this is true, because if you go back to the graph that we have here, notice that that negative 3 matches this negative 3. Now, let's do the same over here. Let's add 1 to both sides, and we get 3x is equal to 1. And if you divide both sides by 3, please keep in mind that we're not doing 3 divided by 1. 1 over 3 cannot simplify any further, so it becomes x is equal to 1/3. Now 1/3, if you put it in your calculator and find the decimal for it, it's going to be 0.33. So if you look right here, 0.33 is between 0 and 1, but it's closer to the 0. So you can see that by having two x's, two different x's, that means we have two different x-intercepts, and we can see that this one matches here and this one matches there. Alright, so I just did a little color coding just so you can see how everything is related, and just remember that when we find these factors and we set it equal to 0 to solve for x, we're actually looking for the x-intercepts of our parabola. So with that being said, I hope this example and my explanation has helped you understand this a little bit better. I'll see you guys in the next video.